This video introduces you to the Spectral Geologist, TSG, software for working with infrared and visible spectroscopic data. Today, we will use HyLogger datasets to investigate hyperspectrally derived mineralogy in drill cores. Choose from over 3,000 HyLogged drill cores, freely available through the National Virtual Core Library. Start by opening the folder containing your HyLogger dataset. A HyLogger dataset contains many files, including multiple JPG files. Ensure that all of these files remain in the same folder in order to successfully open your dataset. Click on either of the files ending with the .tsg extension. There are two separate TSG files for the different wavelength regions. It doesn't matter which you open, as the two files are linked within TSG. There are 8 main viewing screens in TSG. Each offers a different way to visualize and work with the data. The summary screen presents an overview of the major mineral types in the drill core, as determined by TSG's automatic mineral identification and unmixing algorithm, the Spectral Assistant, TSA. The TSA results are divided into 3 categories according to wavelength region: visible near infrared, shortwave infrared, and thermal infrared. Use the Set pull-down menu to switch between regions. Each of the 3 wavelength regions yields different mineral results, because different mineral types have characteristic spectral features in some regions, but not in others. You will note that TSA results are characterized as system or user. System refers to unsupervised results, while user results have had some guidance from the analyst and are usually more dependable. You can also switch between examining the data on a mineral, group, or elemental level. The spatial plot on the summary screen is a simple way of showing, at a glance, zones and variation along hundreds of meters of drill core. Depth of the drill core is along the x-axis, with TSA results binned in intervals specific to the dataset. For each bin, the TSA-derived amounts of one or more mineral groups sum up to 100. In this drill core from Greenbushes lithium mine, we can see that the upper half contains significant amounts of pyroxene. That's the major lithium ore mineral, spodumene. There's also quartz, mica, and a bit of plagioclase. Plagioclase and K-feldspars increase their dominance in the lower half of the core, and there is less pyroxene. Then we see an abrupt change from ore body to the amphibolite host rock in the bottom 10 meters of core. There are also narrow bands of host rock here and here. Please keep in mind that TSA results should be used as a first pass interpretation only. Being an automated technique, TSA does make mistakes and can only identify minerals that have standards included in its inbuilt spectral reference libraries. As you will see, TSA is just the tip of the iceberg of information that can be extracted from spectral data. Also, please be advised that the numbers provided by TSA are not quantitative. They refer to the amount of the various mineral spectral standards used to model the spectrum collected by the HyLogger. The log screen displays data for each spectrum collected from the drill core. You can visualize data such as depth, TSA mineral matches, and different spectral parameters. Select the data type by right-clicking the column and selecting Item to Plot. and the way the data is displayed by selecting Plot Format. Adjust the number of columns by right-clicking and selecting Edit, Add, Delete, Number of Columns. Clicking on File, Export to CSV, Scalars, allows you to save all data displayed on the log screen as a CSV file readable by other applications. The Spectrum screen allows you to individually view and examine all of the spectral signatures collected from the drill core. They can also be compared to the mineral standard spectra contained in TSG's inbuilt spectral reference libraries. By selecting from the Layer pull-down menu, you can view spectra in a variety of ways, such as in their raw state, reflectance, as continuum removed spectra, Hull quotient, normalized, or as derivative spectra. Clicking on the primary associated button lets you toggle between spectra in the visible near to shortwave infrared regions and spectra in the thermal infrared region. Right-click in the window and select Scale to adjust the wavelength range within the region. The Stack screen allows quick viewing of multiple spectra at once. You can change the number of spectra displayed by selecting the sample height. You can move up and down the drill core using the scrolling panel to the right. The spectra can be coloured by various scalars. Switch between visible near to shortwave infrared and thermal infrared, or view all at once by selecting from the pull-down menu in the top left of the screen. You will notice a gap between 2,500 to 6,000 nanometers. This is the mid-infrared region, not currently collected by HyLoggers. The Scatter screen allows many scalars to be plotted against one another. View all data, or a particular subset, by selecting from the Scope pull-down menu. You can select the type of plot from the Type pull-down menu and adjust the number of plots displayed here. Choose the data to plot on the X and Y axes from the pull-down menus here. To toggle between data associated with visible near to shortwave infrared and thermal infrared, click Switch to Primary, Secondary Dataset at the top of the pull-down menus. I would like to plot drill hole depth against the depth of the spectral absorption feature at 2200 nanometers, which corresponds to the abundance of minerals containing hydroxylated aluminium cations, such as mica. Plots can be coloured to add a third dimension to the data. Click the colour wheel icon and select the data from the AUX pull-down menu. I'll colour this plot by the wavelength position of the 2200 nanometer absorption feature, which indicates changes in the mica composition. Adjust the data ranges with a right mouse click in the plot window and select Scale. I'm constraining the wavelength range the plot is coloured by to make subtle variations more obvious. Bring higher valued data points to the foreground by right-clicking the plot and selecting AUX Color Scalar Sorted Plot Order. So now we can see changes in the abundance and composition of white mica throughout the entire drill hole. This can, for example, enable geologists to better understand alteration zoning in a mineral system, which might relate to different ore grades or proximity to ore. To save an image of your plot, right-click and select Graphics, Save to File. We will discuss the many further possibilities of the scatter screen in an upcoming video. The trace screen shows high-resolution RGB imagery of the drill core and scalars for the corresponding spectra, such as TSA match. The scalars can be chosen from the Plot 1, 2 and 3 pull-down menus at the top. Move between trays using the pull-down menu and arrows in the top left of the screen. The whole screen can be used to create visual summaries of your drill core. You can visualize the whole drill core or just a section by adjusting the span. The binning can also be adjusted to the desired level of resolution. All data can be viewed, or just a subsection, by adjusting the scope. Toggle between the primary and associated datasets by clicking the radio buttons, and select the data type from Plot, Image, Spectral, Class, or RGB. I'll begin with an image of the drill core. Select Image, Construct Image from Line Scan, and Create. Plot TSA matches by clicking Class and selecting from the Class Scalar pull-down menu. I'd also like to plot a lithium geochemical assay which was collected from the core by the Geological Survey of Western Australia, and a spectral match on spodumene, created using TSG's AUX match function, and a spodumene spectrum from our spectral reference library. Adjust the plot displays by right-clicking the column and hovering over the plot option. For those with a premium license, the PLS screen allows you to build partial least squares models to calibrate the HyLogger data. This is a powerful technique which allows quantitative measures such as mineral abundance and geochemistry to be extrapolated from a small, representative set of calibration samples throughout the drill core. However, it requires a little more explanation, which will be covered in a separate video. In addition to the 8 main screens in TSG, there are also floater windows which can be used for a variety of purposes, such as displaying spectra, TSA modelled spectra, to create a scratch pad collection of spectra, or view RGB imagery of the drill core. Switch between the visible near to shortwave infrared and thermal infrared regions by clicking the PA button. Up to 4 floaters can be used at once and are an excellent way of simultaneously viewing the multiple data types HyLogger datasets contain. Finally, all of the main screens and floater windows in TSG are interconnected. Clicking on an interesting section of drill core, data point, or spectrum jumps to that same interval in the other screens and floaters.